We are doing AMATS paper October November 2014 paper 2 question 11a. In this question we are supposed to show that the derivative of this expression will be equal to this expression here. To differentiate this expression here, we're going to use the quotient rule. Okay, the reason for using quotient rule is because this is a variable divided by another variable. When a variable divided by another variable and we need to do a differentiation, we have to apply the quotient rule. Quotient rules say if you have a u and u divided by v, if you want to differentiate this expression, you square the v first at this position, keep the v, differentiate the u, minus keep the u and differentiate the v. Okay, let's apply this formula to this expression here. Let's start to prove from the left hand side of the expression. So this is the u and this is the v. For the v, we are supposed to square it, keep the v, and differentiate the u. Differentiate x respect to x will give us a 1, minus, now you keep the u, and differentiate the v. This v can be seen as 2x minus 1 to the power half. If we are going to differentiate this, we are going to bring down the power half. Power minus away 1 will give you a minus half, and you differentiate whatever inside the bracket. I'm applying chain rule. Okay, let's simplify this expression. Normally we will take out the common factor. For this case is 2x minus 1, and we'll try to take out the smallest power. The smallest power between this and this will be 2x minus 1 to the power of minus half. We'll take out 2x minus 1 to the power of minus half then. So if I've taken out this, so for here I left with 2x minus 1 to the power of 1. Why 1? Because 1 plus the power minus half will give us the power positive half. So minus away, this can be cancelled away. So I left with a x here. Now I'm going to bring down this expression here because this is a negative power. If I bring down, it will become a positive power. So the expression will be 2x minus 1 to the power of positive half. And this expression here, square root and the square cancel away, we left with 2x minus 1 to the power of 1. This expression here, 2x minus x will give us x minus 1 here. Now if I were to simplify this expression, the base is the same, I can add up the power. Half plus 1 will be 3 over 2. Now let's see what we are supposed to prove. We are supposed to get this expression here, x minus 1. We have this expression here somehow must be equal to this expression. Okay, why is that so? Now, this one I can rewrite as 2x minus 1 to the power of 3 whole thing raised to the power of half, because square root is to the power of half. And if we multiply the power together, we'll get this expression here. Okay, so maybe I'll work backwards from here. What I'm going to do is try to make this expression the same as this. 2x minus 1 raised to the power of 3 whole thing raised to the power of half. Okay? This and this is the same. If you multiply the power together, it will give you 3 over 2. And this is actually equal to square root of 2x minus 1 to the power of 3. Square root because of this power of half. Okay, so we have proved that the left hand side equal to the right hand side. Okay, shown. In this question, we are given the equation of this curve, and we are given that this straight line intersects the curve at the point AB. We are told that the gradient of this straight line is m equal to 1. And we are asked to verify that the y-coordinate of B is 3 over 2. To find the coordinate of B, we need to find the intersection point between the curve and this straight line. That means we need the equation of this straight line. Once we can get the equation of this straight line, we solve a simultaneous equation with this curve, we'll be able to find the intersection point. To find the equation of straight line, we need two things. The first thing is the gradient of the straight line, which we are given. 1. The second thing is one coordinate point in the straight line. In this case is the coordinate A, because A cut the x-axis and it lie on the curve as well, and the equation of the curve we are given. So let's find the coordinate of A first. Cut x-axis, y equal to 0. We're going to set the y to be 0 to this equation. We're going to solve for x. So x will be, take the value of 1. This means the coordinate of A is 1, 0. Now we are ready to find the equation of this straight line AB. We know that the A take the coordinate of 1, 0 and the gradient of AB is 1. We can make use of the formula of gradient. Y minus 0 divided by x minus 1 equal to the gradient 1. So from here y will be equal to x minus 1. So this is the equation of AB. Y equal to x minus 1. Now we are ready to solve a simultaneous equation of this curve and the straight line. Okay, so we are going to equate the two equations together. Therefore 8x minus 1 over square root of 2x minus 1 cube is equal to x minus 1. Let's bring over this expression. From here I'm going to bring everything to one side to make the other side of the equation to be 0, and this will give us this expression here. Now if we can factorize this expression, then we can able to solve for x. And it's possible to factorize because there is a common factor x minus 1. So I'm going to take out x minus 1. I left with 8 minus square root of 2x minus 1 cube equal to 0. So x minus 1 equal to 0, x equal to 1, or this expression here equal to 0. So bring this over. Now what I can do is I'm going to square both sides so that to get rid of this square root. 8 squared will give us 64. Okay, then cube bring over become a cube root. So 2x minus 1 equal to the cube root of 64. Cube root of 64 is a 4. So from here we can solve for x. X will be equal to 5 over 2. We have solved the simultaneous equation of this straight line and this curve, and we get x equal to 1 and x equal to 5 over 2. X equal to 1 is the x coordinate of A. X equal to 5 over 2 must be the next intersection point, which is a B. So x is 5 over 2, but we are supposed to verify that the y coordinate of B is 3 over 2. So we are going to substitute the x by 5 over 2 into the equation of this curve. And we get the coordinate of 3 over 2. Therefore, the y coordinate of B is 3 over 2, shown. In the last part of this question, we are asked to find the shaded area. This shaded area is actually made up of area under the straight line here, which is a triangle, and the area under this curve. Okay, we know that the x coordinate of this point is 1. The x coordinate of this point is 5 over 2. The x coordinate of this point is 5, because this is a vertical straight line, x equal to 5. So let's find the area of A1 first. A1 will be this one. So area of A1 will be equal, this is a triangle, so I can use a formula for a triangle to find the area. Half times base, which is 5 over 2 minus 1, this length here, multiplied by the height. The height will be the y coordinate of B, which is 3 over 2. This will give us 9 over 8 unit. square. Now I'm going to find the area under this curve here. I call this area A2. So A2 will be equal to integrate from 5 over 2 to 5, and the equation of the curve is this. Now we're supposed to integrate a complicated expression like this. From question 11a, we know that the differentiation of this result is this expression here. And this expression is actually this expression over here. So if I were to take out the 8 here, we will notice this expression and this expression is the same. Since I know that differential of this expression is this, so if I were to integrate this expression, I must get back this result here. Therefore, integrate this expression, I will get back this result. Five over 2 to 5. I've substituted the 5 into this expression, minus away 5 over 2 into this expression. This will give us the value of 3 and 1/3. So remember to add up the two areas together. So the required area will be the area of the triangle plus the area under the curve. This will give us the result of 4 and 11 over 24 unit square.